Okay, numbers 15 through 18 on the Unit 3 review. These are the problems that are dividing with complex numbers or dividing with pure imaginary numbers. This example, number 15, the denominator has a pure imaginary number. And number 16 is an example where the denominator has a complex imaginary number. Oops, there we go. Okay, this is a pure imaginary number because it only has the imaginary term. It only has the I term. There is no real number that goes along with it. This is a complex imaginary number because it has the real part and the imaginary part. Okay, this one I'm going to even rewrite as minus 1i just to make sure that we see how they're parallel. So this is the imaginary part, this is the real part that this problem is lacking. All right, our goal when we're dividing by an imaginary number is to get that imaginary number out of the denominator. The best way to get an imaginary number out of the denominator is to end up with an I squared, because we know that I squared equals -1, and I can substitute in -1 for that I squared to get that I out of the denominator. So when I have a pure imaginary number, all I have to do to get an I squared in the denominator is multiply by I over I. Remember, I over I means that I'm really just multiplying by 1, so it doesn't change my function, but yet it's going to give me an I squared in the denominator, so I'm going to go ahead and multiply it in. So 8i over -10i squared. Okay, now I need to simplify, so 8i over -10 times -1, because I squared equals -1. And that's going to give me 8i over 10. And then I can reduce, and that will give me 4i over 5. And so now I no longer have I in the denominator, and I have completed problem 15. So that's an example of dividing by a pure imaginary number. Here is an example of dividing by a complex number. A complex number, again, has the real number and the imaginary number. Anytime I divide by a complex number, I have to multiply by the conjugate. Okay, we talked about this too with factoring. We're multiplying by the conjugate because then we will end up with a difference of squares. So we will end up with the first term squared minus the second term squared. And how do I do a conjugate? How do I make a conjugate? I'm going to take my original denominator right here, so -6 minus 1i, and I'm going to change this in between operation. So here I have minus 1i, here I have plus 1i. Everything else stays the same, so it's still -6, still -6. Here it's -6 minus 1i, here it's -6 plus 1i. Then I'm going to distribute in the numerator. So -12 plus 2i. And I'm going to end up with a difference of squares in the denominator, but I'm going to FOIL and show all of my work here. So -6 times -6 is 36. -6 times 1i is going to be -6i. -1i times -6 is plus 6i, and that was the whole point of multiplying by the conjugate, that those two are going to cancel each other out. And then last but not least, minus 1i squared. Okay, or minus I squared. All right, now I can substitute -1 for that I squared. So let me write over here, -12 plus 2i, 36 minus -1. So now -12 plus 2i. 36 minus a -1 is really 36 plus 1. So 37. So the final answer for number 16 is negative 12 plus 2i over 37. Okay, number 17. Number 17, also dividing by a complex number. Because we have a real number and imaginary number. So anytime I'm dividing by a complex number, I'm going to multiply by the conjugate. Okay, so still negative 8. Here it was plus 4i, so I'm going to multiply by the conjugate negative 8 minus 4i. Distributing in, so negative 24i minus 12i squared. And then down here on the bottom, I'm going to show all my work. So positive 64, there we go, plus 32i minus 32i minus 16i squared. Okay, now I have I squared in two places and I need to substitute in negative 1. So 24i minus 12 times negative 1. 64 minus 16 times negative 1. So now I have negative 24i plus 12. And then in the bottom I have 64 plus 16. I need to rewrite this because, first of all, my imaginary term needs to go second. So 12 minus 24i, so real number, imaginary number. And in the bottom, it's going to be over 80. When I add 64 plus 16. And now I can reduce. So I can reduce by taking 4 out of each of these things. So I'm going to factor out a 4. Here's what we're doing for the second half of the chapter, right? I'm going to factor out a 4. So that leaves 3 minus 6i. Factor out a 4 on the bottom. Okay, those 4's cancel. And so my final answer is 3 minus 6i over 20. Okay. And number 18. Again, I have a complex number here. So I'm going to multiply by the conjugate. So actually, look what I did there. So let's talk about this. 3 plus 4i, that's not the conjugate. It's not 3 plus 4i. It's 3 minus 4i. So I have 3 plus 4i here, so the conjugate is 3 minus 4i. So I'm going to need to FOIL on both the numerator and the denominator. So 15 minus 20i plus 18i minus 24i squared. Okay, denominator, 9 minus 12i plus 12i minus 16i squared. Those two I terms cancel out. All right, up here I'm going to combine like terms. So 15 minus 2i is the negative 20 and the positive 18, minus 24 times I squared. I squared is negative 1, so I'm going to substitute in that negative 1. On the denominator, 9 minus 16 times I squared, which is negative 1. All right, so now I've got 15 plus 24, so that's going to give me 39 minus 2i. And in the denominator, I have 9 plus 16, 25. I cannot reduce, so my final answer is going to be 39 minus 2i over 25.